Hello everyone. This video is going to be about the introduction of a new product I've been working very intensely on for the last 3 months. It's been the subject of some intense thought, R&D, design, manufacturing, working out the bugs. It's been a real challenge, but I think I've persevered, and I think the product will speak for itself in this video. Okay, what I have here is I have obviously two stripped down Sony PS-X800s, and what I'm going to be showing you is the difference between the resonant characteristics of the two turntables. One is modified, one is not. The one that has my new supplemental plinth is the one on the left, and a stock one is on the right. And I'm going to be doing some mechanical impulse testing to show you the differences between the two. Both turntables internally are identical. The parts are all intact. All screws have been double checked for tightness. All of this was done to make the tests that you're going to see here in this video as valid and legitimate as possible. The turntable on the left is a turntable that suffered some abuse in shipping because it was not packed properly. These Sony bulk molded compound plinths, the SBMC plinths, are the most delicate plinths of any of the direct drive straight line tracking turntables that I work on. You absolutely must pack these things correctly, or you will have devastating damage. The damage in this particular case should be fairly clearly visible right here. Okay, you have a whole chunk missing out of this. So I can't overstress this. Whenever you ship these to anyone, it must be packed properly. And if you need packing instructions, even if you don't want to work with me, just send me an email and I'll get that out to you, because I don't want to see these things broken like this anymore. It's a tragedy to see this happen to a vintage turntable, especially one of this caliber and rarity. Okay, now that I've gotten that off my chest, the supplemental plinth I've designed is comprised of aluminum of varying thicknesses, damped by rubber sheet between them, and the total laminate count is 6 on this particular supplemental plinth. The future supplemental plinths will have varying laminate counts, but the one that will replace this in the future will have 1 laminate less. So instead of 6, it will be 5 aluminum plates and 2 damping sheets. I will refer to that as the 3-2 version, meaning 3 aluminum plates and 2 damping sheets. And the reason why I call it a 3-2 and not including the extra 2 for a total of 5 is that the extra 2 are just a cosmetic peripheral ring. And just it's the only reason it's there is to just build up the area between the bottom of the plinth and the top of the supplemental plinth. This particular supplemental plinth weighs about 23 pounds, and it's extremely dead. It's as dead as I can make it for the size and weight restrictions and objectives that apply here. So anyway, I will show you more about what that looks like later on in the video, but right now I just want to go over the differences in the resonant characteristics between these two turntables. Again, these things are identical, so I don't want to hear anybody say that they're not, because they are. With the exception of the armrest missing on that turntable. We really want to get picky. I mean, it could really be ridiculous here. But anyway, let's get on with this. I'm going to be subjecting these to a mechanical impulse stimulus of several different types. I think the most valid is a rubber mallet hammer. And that's another thing. One of my past videos, somebody criticized my video saying that I was using too much force. I think the words they use is too hard. Well, let me tell you something. I'm a very careful person. I know what I'm doing. I do not subject any component, any apparatus to energy that's I consider excessive. I'm always very respectful of everything I work on. And during this test, yes, you will see some mechanical impulse testing going on. However, you would not be able to get a feel for the differences between these two and what the heck I've been up to for the last 3 months in a very intense fashion, unless I provided some mechanical impulse testing. So enough said about that. Let's get on with this. Okay, here we go. Here's the stock PS-X800. I'm going to provide a mechanical impulse test at the edges of the arm shaft. And in case you don't know, this is what the tone arm rides on, this polished stainless arm shaft. Okay? And we'll test it here, and then we're going to test it at the spindle, and then at various points on the plinth. Now, the other various points on the plinth are not nearly as important as these points here and here. Okay, this is where the energy is coming into off of the tone arm that originates from the cartridge, and over here, of course, you know, we have energy coming in from the record through the mat and then into the platter, etc., etc. And then, but more importantly than that, energy coming in from the environment, coming up through the spindle, into the platter, into the mat, into the record, etc. So anyway, let's get on with this, and I've made it as quiet as I possibly can in here. I do not have an external microphone, so I can't do close mic placements here. You're just going to have to, you know, roll with this. Here we go. Okay, I personally consider the rubber mallet hammer to be the best overall mechanical impulse testing tool to use for this particular application. If you want to see a knuckle wrap test, now, if you said that this is louder than this, you'd be right, despite the fact that this has a supplemental plinth. But remember, I'm mechanically coupling the perimeter of the original OEM plinth to my supplemental plinth, and so that's making it more rigid, which builds up a little bit more of a signature, but it's really just a different signature, a higher frequency signature than this. Okay, again, the OEM plinth resonant characteristics are not nearly as important as the new characteristics that we have here at the arm shaft and the spindle, okay, the motor spindle. And the reason why is these are active parts. The rest of the OEM plinth is a parasitic, just a basic structure that supports the electronics and transformers and so forth. So we're not asking that to really do anything special. What's important is the arm shaft and the motor spindle. Okay, now I've decoupled the arm shaft from the OEM plinth. I've also done the same thing with the motor spindle and the motor itself, actually, from the OEM plinth. So that's important, and I've rigid coupled it directly to my supplemental plinth here. Okay, hopefully that is enough for you guys to be satisfied with as far as evidence of the difference between the two. Certainly the added mass of 23 pounds to the base of this, and to replace the existing flimsy weigh virtually nothing bottom cover, that alone would make a big difference. I'm going to move this one out of the way, and then I'm going to introduce my supplemental plinth. Okay. It's a considerable weight now, for sure. Again, you're talking an extra 23 pounds over the original. I believe it's about 25 pounds rated. And so now it puts it up into a pretty respectable category. Here's what we got. Sure that this is centered well in the camera. Not too bad. That'll have to do. Hopefully you can see this fairly well. Let me see if I can zoom in a little. Okay. I'm really proud of this thing, and I should be. I put so much time and effort into this. I feel it's a precision piece of gear, an incredible upgrade. It's just, I don't mean to brag, but I am proud of this. All the original feet simply thread back into the original locations, and so that makes it nice. I tried to make this as friendly to the original design as possible. These are the tone arm mounting points, the arm shaft mounting points. These are the motor mounting points. As you can see, I've left out one of the motor screws here, and the reason is that I'm concerned that if somebody were to take this plate off and flip the turntable on its side or over or whatever, the whole motor would break away from the circuit board, and we can't have that, obviously. So as a safety precaution, I leave one screw in, but I decouple that screw. These are all the perimeter screws. This one's missing because this whole piece is broken away here, like I told you before. And this is a nice black wrinkle finish. It's got full ventilation, okay? And these ventilation points are over the hottest parts of the circuit boards. I do not provide ventilation over the system control board, because none of the components there really run very warm at all compared to the other boards. And there's so many calibration pots there, I really don't want to run the risk of getting dust and contaminants in there to interfere with the calibration, so I elected not to do that. Besides, there's plenty of clearance between the top side of the supplemental plinth and the circuitry on the system control board. This, you might think, well, it's still not dead enough, but I'm telling you, this is all constrained layer. I've personally selected the best damping sheet products that I could find, and I tested a lot of different ones, and it's considerably dead and respectable compared to a lot of other structures. Now, if I do a test here, you'll see what I'm talking about. This is like concrete here. This is very, very dead. And I'll bring in my hammer, and all we basically hear is the hammer. So extremely dead, okay, when tested on the on-axis like that. Obliquely, transversely, yeah, we get a little bit, but what do we expect? I mean, this is about 1.25 inches total, 1/2 inch of which is being used by the cosmetic peripheral ring, which doesn't really do anything structure-wise. So, within our size constraints and budget constraints, this is a very practical, and weight constraints, this is a very practical decision to make design-wise. So I don't want to show you how it installs, because I originally conceived this to be user installable, and I may eventually get around to that. But there's shimming operations and just complicated, delicate stuff to do, and right now I'm just going to offer this as a service that I personally install. I just don't feel comfortable having anyone else install this at this time. Later on that may change, but as of now, that's where we're at. I'll see what I can do about getting a side view on this. Okay, let's take these off. And also, this maintains the original transit screws. So those are these two holes right here. They're threaded, so you have the same functionality of the bottom cover that you always had. So it maintains the use of the transit screws, no problem. Now, here you go. You can see the laminate construction here, okay? Hopefully that's pretty clear. If not, let me see if I can get a flashlight to help. All right. All right. What else? We don't need that right now. I'll show you the bottom cover. Probably already know what this is all about, but this video is, you're just going to have to be patient. This video is kind of awkward because there's a lot of moving things around and fun stuff like that. So, okay. All right. Now, the bottom cover. This is what this looks like. If it weighs a pound, it weighs a lot. Okay. And these are the transit screw locations, by the way. Some people, when they ship me PS-X800s, they don't read the user manual or something, and this seemingly simple situation here of finding two transformer transit mounting screw locations. They can't seem to find it. So anyway, this is where it is. You put two screws in here, two 4mm screws. They have to be special screws with a conical shape at the end, but anyway, you don't take these two screws out. You leave those in. Matter of fact, you want to make sure they're tight. You don't take out any of these other peripheral screws or these two center screws. These are the transit screws. Okay, again, this is, you know, the bottom cover. Alright, so it does absolutely nothing to improve the mass, rigidity, inertness, anything for this turntable. All it is a bottom cover. It also lets fairly large bugs come in here, and that's why I'm using very small holes in mine to minimize that chance. One thing you might have noticed is that around the periphery of this supplemental plinth, right here, okay, there is a gap. Yes, I understand that. I'm still waiting on the proper open cell foam to use here. That's what I elected to, you know, enclose the space to keep possible bugs from getting into the electronics area. But I don't have it right now, so I can't show you that, and I really wanted to get this video on YouTube as soon as possible. So anyway, you'll have to bear with me. That will be addressed here soon. Okay, next video is going to be showing you the difference between my tone arm modifications and a stock one. Just as a teaser real quick, this is not meant to be a full proper video, but this is just a prototype, you know, arm housing that I've been working with. This is carbon fiber. There's no need to really show you, you know, the finish on it, because this is not going to be the original, this is not going to be the finish that I'm going to be offering. But here's the resonant characteristics of this after extensive modification and significant time investment. Okay, very dead. And here's an unmodified stock arm housing. Alright, need I say more? I will say more soon when I do that video, but right now I think you would agree with me there is a significant difference there. Alright, thanks a lot guys. That's it. Talk to you next time.